Once you extract the GML graph, you can open it in Visual Studio. Here we have a SAME graph database codebase as an example. The graph contains both namespaces and vars. The main challenge when visualizing dependencies is there are too many elements, so by default namespaces that contain only vars are collapsed. You can collapse namespaces further to get more clarity, and we can relay out top to bottom to see it clearer. And then when we have the big picture, we can expand individual namespaces and drill down. Another feature is that links are aggregated, so they are only shown across namespaces. And to see the links from individual functions, you can select them. And this is useful because if we shown all links by default, it would be too messy. And so I pressed Ctrl A to select all, and we see all the links. So we can explore individually, and here we see this function depends on the memory namespace, and there's one link. If we expand, you can see there are actually more dependencies on individual functions, but when we collapse, you can see only one link. Another use case is local exploration to see how a particular functionality is implemented. And let's say I would like to learn how the queue function for querying is implemented. So you can see it depends on the query namespace, but when I expand it, it's a little bit overwhelming already. So we can use the browse neighborhood mode and only show one link away from the selected function. For this view, the left to right layout works the best. We can see it depends on the query entry function. And we can recenter using the butterfly button. So this way we can traverse the call graph, and here we can see other functions like parsing, executing, and aggregating the query. And another way how to view the functionality, if I first collapse everything, and let's say I'm interested in parsing, how it is implemented, so I'm gonna search for the parse function. Here we can see it in context, it's too much, so I switch to the neighborhood mode, I show one link, or can expand it to 2 links or more. And here we can see all the functions that are referenced from the parsing. Another example is the Promessa codebase. Here we can see different colors representing different elements. You can open Legend to see different categories. We have namespaces, functions, macros, and other vars. And when we hover over the elements, we can see details. You can see the macro category and defined by def macro. Here there's a var defined by def. This one is var defined by def once. And for private elements, they are dimmed and shown with dashes. This code base, it's also a little overwhelming by default. So we can right click and collapse all, and then expand and see the big picture, and expand eventually and go from there. Visualization of dependencies can also help us with refactoring. In this project, I'm going to focus on a viewer namespace which contains various UI components. Let's say this namespace grew too large and we'd like to refactor some functions into a separate namespace to make it more manageable. When we see the relationships visually, we can identify clusters, which are usually good candidates for extractions. In this example, we have a cluster over here. I'm going to shift drag to select the functions. And I'm going to simulate refactoring by creating a group. I'm going to name it data grid. We can also see additional dependencies. For example, this paginate table results. And you can use selection of outgoing dependencies to see more. And there are no other dependents. So these are also good candidates to move in, and we can drag them over and add them to the namespace. You can see the resulting structure is much tighter than what we started with, and we are able to use the visualization to come up with refactoring plan to improve the code structure by extracting the following functions. To customize the extracted graph, you can provide additional options on the command line. You can see the list of available options in the help message. By default, namespaces are grouped into a nested hierarchy, but you can pass the flat namespaces options to prevent that. By default, also links to third-party dependencies and libraries are excluded, but you can include them using the include dependencies option. The flat namespaces view looks a little bit messier than the nested hierarchy, but it can be useful sometimes to provide additional insights about the dependencies. And when we see the dependencies, it also includes Clojure namespaces, and we can see the libraries and which part of our code base depend on those. So final tip to learn more about the editor: you can create a new file and choose the directed graph document. And here are the links about the keyboard shortcuts, for example, minus to collapse groups, plus to expand, and selection of incoming or outgoing nodes, and also help for the mouse behavior, so you can see how selections, dragging behaves.